Hi there, my name is Ian, and today we're going to be exploring grade 11 analytical geometry. Analytical geometry, two-dimensional geometry. Let's start. Well, first of all, the distance formula is something that you have to know. In fact, it's on your formula sheet, so you don't have to commit it to memory. Like many of these formulas, they're on the formula sheet. So this is an area that you can do really well in. Use the right formula, you're probably going to get all your marks. We're going to look at the midpoint formula, the midpoint, the middle between 2 points, the middle of a line segment, the gradient of a line segment joining 2 points, exactly the same m, slope, gradient, same thing, the gradient of a line segment, the slope of a line segment, just like we started learning in grade 9 when we did straight lines. And there it is, equation of a line. Now, I'm going to be running through two methods. Both formulas appear on your formula sheet. You'll no doubt pick up which one I prefer, but I'm going to do what I refer to as the grade 9 version and what I really love, the matric version. We're going to be talking about parallel lines and perpendicular lines. What happens with the slope if the lines are perpendicular, or the slope if the lines are parallel to each other? An interesting concept, collinear points. I mean, just pick that up. Co, together, linear, on the line, points. So points that lie on a line. So I could have A, B, C. How do I know that they lie on a straight line? If they weren't on a straight line, ABC would be a triangle. So how do we get to prove that they lie on the same straight line? And I'm going to do a couple of different methods, and you can choose which one you prefer. Angles of inclination. Angles of inclination, a little bit of trigonometry thrown into analytical geometry. What is the angle of the line? How steep is it? Quadrilaterals. Now I know last year, well I'm sure last year your teachers emphasized quadrilaterals, their properties. What we need to know is their properties, and from that we can pick up the coordinates of their vertices, the corner points, the vertices, and other properties. Do the diagonals bisect? And where they do, is that the midpoint? Bisect, chop in two. Midpoint, chops it in two. The equation of a circle. Now the equation of a circle in grade 11 is always center 0, 0. And in grade 12, that center starts spinning around the Cartesian plane. And to finish off, I'm going to look at triangles. I know that you know the difference between isosceles triangles, obtuse angle triangles, right angle triangles. But how would I prove that a triangle is right angled? How would I prove, using analytical methods, that it's an equilateral or an equiangular triangle? Same thing, equiangular, three angles that are the same. An equilateral, lateral meaning sides, the length, equilateral triangle. How would I prove it? Right, let's kick off with our first concept we're going to discuss. The preamble, the little thing that goes before, is if AB is the line segment joining the points, and please note the way this is notated. X subscript A, that means down the bottom on the right-hand side, means the x value of the A point. So A is XA, YA, and point B has XB, YB. It just helps us differentiate so that we don't make a mistake when we start substituting values into a formula. The first one we're going to look at is the distance formula. Now, on the formula sheet, you get AB is equal to the square root of xb minus xa all squared plus yb minus ya all squared. You could also, on your formula sheet, get x2 minus x1 plus y2 minus y1. Exactly the same thing. You just decide which point is going to be point 1 and which point is going to be point 2. It makes no difference. It's your choice. Let's do a little example. Well, if I have point A over there, and I'm not drawing a full Cartesian plane, I'm just going to put this in mid-space, that is the point 2, 4. And I have a point over there, point B, which is the point 3, 8. What is the distance between them? I'm going to use the distance formula. It gives it away. What is the distance? We use the distance formula. So the distance AB is equal to the square root of. I'm going to use point B as my first one, just like the formula on this tablet has got it. So I will have 3 minus 2 all squared plus 8 minus 4 all squared. See, I've got the x value, the difference of the x values, all squared, plus the difference of the y values, all squared. You could use your calculator if you wanted to, and plug it in exactly as it appears on screen. Square root, put your brackets in, put your squares exactly in the right spots. I'm going to do it long-handed. Well, 3 minus 2 gives me 1, and 8 minus 4 gives us 4. So under here, I'll have 1 plus 16, which is root 17. Now, just remember, root 17 is the most accurate answer you could give because it's got an infinite number of decimal places. If you are asked for 2 decimal places, well, let's bring up the calculator and do that. Well, square root of 17, thanks to our Casio calculator, is 4,12. And going to write that down, 4,12. I'm going to bring the calculator back up again, just to make sure you know which button it is to press to go from surd notation to decimal notation. If you look on the calculator, there's a little S, a little arrow to D. It's that button over there, surd to decimal. Absolutely magic. Right, that's enough of that. Let's move on to our next one. It starts with the same preamble, and we talk about the midpoint formula. I have point A and point B, and directly in the center, we have our midpoint. Please note that it's the sum of the x's divided by 2, the average, the mean, and the y coordinate will be the sum of the y's divided by 2. Let's choose 2 points. I'm going to choose point A over here, and what values should I use? All right, 3, 7. That's the point 3, 7. And the point over there, B, will be the point 7, 5. What is the point C in the middle? Or would you prefer me to use M because we're talking about the midpoint? Let's use M. Well, let's do our calculation. M will be the point 3 plus 7 divided by 2, and the y coordinate will be 7 plus 5 divided by 2. And yes, you've got it right. That is, M is the point 5, 6. Very simple calculation. Remember, the sum of the x's divided by 2 and the sum of the y's divided by 2 gives you the midpoint. I'm going to give you a question. What happens if you had to find a perpendicular bisector? What does bisect mean? Let's have a look at a little diagram. If I had my line AB and I had to do a perpendicular bisector. Bisect means it cuts it in the center, in the middle. And perpendicular means it would be at right angles. How would I find out where it was going to cut? Yes, you got it. Use the midpoint formula. The point of bisection and the middle point are the same thing. So A to our point of intersection, and I'll just call that P because we can, is going to be the same as B to P. So there we go. Another question using the midpoint formula. All right, our preamble starts again, and we look at the gradient of a line segment. Now, I know that some of you will call gradient slope. I know that some of you will call it rise over run. I know that some of you might even use the Greek letter delta, delta y over delta x. That means the change in y over the change in x. They are all exactly the same. The formula over there is the formal way of writing it. y2 minus y1 over x2 minus x1, or, as we have it on screen, yb minus ya over xb minus xa. The change in y's over the change in x's. Now once again, on your diagram, the points might not be point A and point B. It might be point P and Q. You choose whichever one you would like to put as the first. I'm going to do a little example. Here I have a line and I'm going to call it PQ. Q is -1, 6. And P would be 3 minus 1. Well, what is the slope or the gradient of this line? Now I know in grade 9, some of you might have drawn a little right angle triangle to help you work out intuitively, that means by looking at it, intuitively, what the rise over the run was. I'm going to do it with the formula. I use the letter M to show my gradient or my slope. Y equals mx plus c, that's the M we're talking about. Well, 6 minus -1 over -1 minus 3 gives me 7 over -4, which we write as -7 over 4. What does that mean? It means the slope has a negative slope. It means it's going down to the right, and it's 7 over 4. Now, when you are driving from Johannesburg to Durban, there are a number of mountain passes you go through. And often, if it's steep, there'll be a little warning sign with 3 is to 1. Now, what that means is for every 3 x's you go along, you're going to go 1 up. And that's pretty steep. So next time you're in a bus, in a taxi, and you're going up a mountain pass, have a look for that little warning sign. It's talking about the gradient, the slope, or the steepness of the road in that case. Here we come to the equation of a line. Now I know that you've done this since grade 9, but perhaps you haven't seen the second formula. That was the traditional one we used in grade 9, which always works. This is an alternative equation which always works. I'm going to do an example both ways, and you decide which one you prefer. Well, let me set up a little diagram first of all. there is a line, and I'm going to call my line PQ. And P will have the coordinates 1, 1, and Q will have the coordinates 5, 9. The first thing I'll have to do, if I'm using y equals mx plus c, is to work out my slope. So, how do we do that? Use the equation for the gradient. So my slope of PQ will be the change in y's over the change in x's. y2 minus y1 over x2 minus x1. Now I'm going to choose my big numbers as x2 and y2, point Q. Because then when I subtract, I won't have to worry about extra negatives. It's making that kind of a decision for yourselves which is going to make it life easy. So I've got 9 minus 1 over 5 minus 1, which gives me 8 over 4, which gives me a slope of 2. I then am going to put this back into my equation. Y equals 2x plus c. Now, I know that I've got to substitute one of my points in. Would you like it to be point P or point Q? Decision is yours. Let's have a look at Q. 5, 9. Point P, 1, 1. That's so much easier to work with. Once again, choose the values which are going to make life easy and your calculations easy for yourself. So 1 is equal to 2 times 1 plus c, and working this out, we get that c is negative 1. Writing this down, y is equal to 2x minus 1. And there's the equation of our line. We worked out the slope, the m, the gradient. We put it into the equation, we substituted in our point, and we tidied it up. We made it look pretty at the end. I'm going to do it using the other formula. Y minus y1 is equal to m into x minus x1. Well, we've already worked out the m, or the slope, or the gradient. And all this requires is one big substitution. Would you like to substitute point P or point Q? I'm going to do point P again. Well, y is y, y1 is 1, m is 2, x stays x, and x1 is 1. And there's the equation of the line. Yes, that is a standard form for the equation of the line. However, many people prefer it in the, let's call it the old-fashioned y equals mx plus c. So what do we have to do with this? We just need to multiply out our right-hand side and make it look pretty. So y minus 1 is 2x minus 2, so y is equal to 2x minus 1. Exactly the same as we got a little earlier. There they are, exactly the same. Right, let's move on. There's our preamble, and we talk about parallel lines. Now, I think it's very obvious that if two lines are parallel, their slopes have to be exactly the same. And that is why, if the slopes are the same, the lines are parallel. The slope of AB is equal to the slope of CD if and only if the lines are parallel. So, what kind of questions are going to be asked? Well, yes, are these two lines parallel? Let's look at an example. There's the line AB, and this is going to be the point minus 2, and B is going to be the point 3, 4. Another line comes in, the line CD. Well, C has the coordinates 1, minus 2, and D has the coordinates 6, 4. Are those two lines parallel? Well, the only way we can find out, And remember, it's analytical methods, so we're not going to do a sketch and then say, of course, it looks obvious. We're using analytical methods, and we're going to prove that they parallel. Working out our slope of AB. Yep, change in y over change in x. So what does that give us? That gives us 6 over 5. Let's have a look for the slope of CD. The slope of CD, 4 minus 2 over 6 minus 1, which gives us 6 over 5. Goodness me. The slopes are the same. There they are, the slopes the same. Therefore, AB is parallel to CD. Nice question. Are the lines parallel? Yes. Then how are we going to show it? Now, another kind of question could be, if the lines are parallel, what are values? Or perhaps this line and this line are parallel, and you've got to find the equation of a second line using your knowledge that if they are parallel, their slopes are going to be the same. Right, let's move on to perpendicular lines. Now, here's a little rhyme. If the product of the slopes is -1, the lines are perpendicular. Now, for those of you who are not quite sure about what perpendicular means, it means at right angles. So hopefully, buildings and the grounds will be perpendicular to each other. A flagpole and the ground will be perpendicular to each other. In this context, analytical geometry, they don't have to be horizontal and vertical lines. So those two lines would be perpendicular. And yes, the product of the slopes would be -1. Let's have a look at it formally. There it is. If the product of the slopes is -1, the lines are perpendicular. How would we prove two lines are perpendicular? Well, work out the product of their slopes. If it's -1, they're perpendicular. Here's a nice question. Prove a triangle is a right-angled triangle. Now, the moment you start saying right-angled triangles, I'm sure you remember your days in grade 8 where you had to learn Pythagoras' theorem. Yes, it would be one way to do it. You get the distance of all three sides and make sure that the sum of the squares of two sides is equal to the square of the other sides. If that happens, it is a right-angled triangle. However, another way would be to show that the product of two of the slopes is -1. And I've got a little example to show you what I'm talking about. Here I have a Cartesian plane, and on this Cartesian plane, I'm going to have 3 points. The point 2, 9 I'm going to call P. The point -2, 1 I'm going to call Q. And the point 2, -1 I'm going to call R. There's my triangle. Now, some of you might say, it looks right-angled, therefore it must be. Unfortunately, we need to prove that it's right-angled. Irrefutable proof that this is a right-angled triangle. And we have to use analytical methods. I'm going to start off by working out the slope of PQ. Well, that's 9 minus 1 over 2 minus 2, which is 8 over 4, which is 2. So the slope of PQ is 2. I then am going to work out the slope of QR. Well, 1 minus -1 over -2 minus 2 gives me 2 over -4, which is -1/2. Well, let's have a look. The slope of PQ times the slope of QR. That will be 2 multiplied by -1/2, which is -1. This is a right-angled triangle, and we can draw in our right-angled without a shadow of a doubt. And I know my diagram doesn't look like it's right-angled. If you drew a diagram to scale using these coordinates, and there they are, it would be a right-angled triangle. So there's another way. If you don't like using the distance formula, you could use this way. If you prefer using the distance formula, you could prove it using Pythagoras' theorem. Moving on. There's our preamble, and we come to collinear points. As I said a little while ago, co meaning together, linear lying on the same straight line, and points, that's what we're talking about. Are there points that lie on the same straight line? By way of a diagram, if I had 3 points that were not on a straight line, it wouldn't be a straight line, it would be a triangle. So if they lie on the same straight line, if they are collinear, the slopes between the points would be exactly the same. Think about it for a moment. If you have your line over here and you have A there, B there, C there, the slopes between A and B, the slope between B and C have got to be identical because it's the same straight line. So what I'm going to do is I'm going to show you how to work this out. Well, if we come along and we have 3 points, for example, point A is the point 1, 3, point B is the point 4, 9, and point C is the point 5, 11. Are they collinear? I'm going to show you 2 different ways to check this out. The first way is using slopes. Well, the slope of AB would be 9 minus 3 over 4 minus 1, which for most of us will be 6 over 3, which is 2. I chose point B as my first point because it had the bigger numbers, and the bigger numbers minus the smaller numbers, I don't have to worry about negatives. Your choice. You'll get the same answer. Let's have a look at the slope of BC. Well, the slope of BC will be 11 minus 9 over 5 minus 4, which gives us 2 over 1, which is 2. That means, taking our example over here again, from A to B we have a slope of 2, and from B to C we have a slope of 2. They must lie on the same straight line. Easy method. Here's a different method. What I'm going to do with this method is I'm going to work out the equation of AB. You could choose BC or AC, whichever you prefer. And then I'm going to take the third point and I'm going to substitute it into that equation and see, does the left-hand side equal the right-hand side? If it does, that point lies on the line. To summarize, work out the equation, test the point. Here we go. Working out AB. I know it's 2. I did it a few moments ago. Which version would you prefer? The y equals mx plus c or the new funky equation where you just put it in once? I'm going to do it that way. Writing the equation out, y minus y1 is equal to m into x minus x1. All right, let's work it out. And I'm going to put in the point A because it has the smaller numbers. So it's y minus 3 is equal to 2 into x minus 1. There I've got it, the equation of the line AB. I'm now going to test the point 5, 11. On my left-hand side, I have y minus 3, which would be 11 minus 3, which gives me 8. On my right-hand side, I have 2 into 5 minus 1, which is 2 times 4, which is 8. That point 511, my point C, lies on the line AB. So to conclude the question, point C does lie on AB. So how can we say, to finish off, therefore, A, B, and C are collinear? Two different ways. Let's just summarize that. The first way was to have a look at the slopes. Does the slope from A to B equal the slope from B to C? If it does, they've got to lie in the same straight line. The second way was to work out the equation of AB and then test point C. If the left equals the right, lies on the line, ABC collinear. Let's move on. Here we come to angle of inclination. What is it? How much incline? Incline meaning steepness or slope. What is the angle of the slope? Now the way I've described it is it's the angle between the line and the positive direction of the x-axis. And the angle will be called theta. Now, some of you might say, why do we always use Greek letters for angles? It's because of the Greek called Euclid, and he did a whole lot of work with angles. And so, in deference to all the work and the knowledge that he presented to us and our forefathers, we just use Greek letters for angles. The equation we have to work with is m equals tan theta. I'll do a couple of simple examples, and then we'll move on to something more tricky, which should be in your exam. There I have a Cartesian plane with a straight line. That angle over there is going to be theta. The angle between the positive direction of the x-axis and the line. That is going to be theta. All right, here we go. What happens if this point over here is the point 5, 3? Right, that first point is the point 5, 3. Let's say that it has a y-intercept of 1. Now, my slope is going to be 2 over 5. How did I work that out? Just to remind you, I can, as I used to do in grade 9, draw a little triangle and say the x's changed 5 units and the y's changed 2 units, and it was in a positive direction. That's why m is 2/5. Now, using our equation, 2/5 will be equal to tan of theta. Yep, here it is, a trig equation. So what we're going to do is pop up our calculator and work out what is the angle theta. Remember, we're trying to find the angle, so the buttons we would press would be shift, then tan, then 2/5. Technically, we're looking for arctan 2/5. Right, bring up our calculator. Shift, tan, fraction button, 2 over 5. Finish off our bracket. Our angle is 21,8 degrees. I'm going to work to 1 decimal place with angles. Please make sure you read the front of your exam booklet to see how many decimal places your examiner would like you to work to. So here we have that theta is equal to, refreshing the memory, 21,8. 21,8 degrees. Our angle of inclination is 21,8. How about if they give you the angle of inclination and you have to find the slope? Let's make a complete exam question out of this. Here is a Cartesian plane, and they tell you that that angle is 60 degrees. They give you a point, and the point we're going to choose today is going to be the point 5, 6. The question is, what is the equation of this line? So, what is the equation of the line? Most of us would look at that and say, we've only got one point, we can't do it. But yep, you're thinking correctly. We can take our 60 degrees, find the tan of it, and we'll have the slope of our equation, of our line. So to start off with, m would be equal to tan of 60 degrees. Bring up our calculator. Tan of 60, root 3. So m is equal to root 3. Right, so y minus y1 is equal to m. Now m is root 3 into x minus x1. Substituting our point, we have y minus 6 is equal to root 3 into x minus 5. That is, as I said before, a recognized standard form for the equation. And there we have our answer. Just in case your teachers or your examiner prefer y equals mx plus c version, let's just tidy it up. So y would be equal to root 3x minus 5 root 3 plus 6. Done and dusted. 2 bits of information, and we use the angle of inclination to work out our slope. Now, a slightly more typical exam question is the one I'm going to put on the screen now. You're given a Cartesian plane with the equation of a line y is equal to 2x plus 2, and the equation of the other line y is equal to minus 3x plus 7. I'm just taking those numbers or those equations as an example. You then ask to find what is the size of the angle alpha. Half-dead fish, alpha. Okay, what can we do? Well, using y equals tan theta, we can work out that angle over there. Remember, it's always between the line and the positive direction of the x-axis. We could then work out that angle over there, and goodness me, we've got exterior angle of a triangle equals sum of interior opposites. We can work out alpha. Right, let's start with this one over here. So we know that m, which is minus 3, and in fact what I'm going to do is I'm rather going to do it right next to the equation. So minus 3 is equal to tan theta. Bring up our calculator. Shift tan, negative 3. Negative 71,6. Remember, I'm going to go to 1 decimal place. Now, the angle the calculator has given us is negative 71,6. Now, if we look at our diagram, that angle over there can't be negative 71,6. What has the calculator actually done? It's given us the angle below the x-axis, between the x-axis and the line. So what we need to do is to add 180 to it, and we'll get that theta is equal to 108,4 degrees. So this angle on top is 108,4 degrees. We just have to be really wide awake and careful. I know that you look at the angle and you say, it can't be 71, because 71 is an acute angle, and that's an obtuse angle. So that should also alert you to find the difference between that angle and 180. Right, let's go to y equals 2x plus 2. We'll have that 2 is equal to tan theta, and we're going to find out what theta is. Pop up our calculator, and we go shift tan of 2, and we get 63,4. So in this case, we get theta is equal to 63,4 degrees. So that little angle in there is 63,4 degrees. Now, I know I said it a few moments ago, but the exterior angle of a triangle is equal to the sum of the interior opposite angles. So that angle 108,4, if you subtract 63,4, what do we get for alpha? Alpha is equal to 45 degrees. Now that's a pretty typical exam question for grade 11. And it will also appear in grade 12. So if you can nail it this year, go for it. That's angle of inclination in a nutshell. Let's move on. Quadrilaterals, their vertices and other properties. Now, the vertex of a quadrilateral is just the corner points. Quadrilaterals, quad, 4 sides. Yep, things like kites, arrowheads, parallelograms, trapezia, rhombus, squares, rectangles. Now, the most frequently examined or the most frequently tested quadrilateral is the parallelogram in the context of analytical geometry. But one thing you're going to need to have to do is to go to your grade 10 book, get it out, and study all the properties of quadrilaterals. I remember in last year's one exam paper, if you didn't know the properties of quads, the one matric question was totally inaccessible. Quite sad if you hadn't bothered to learn those properties. I'm going to come back to quadrilaterals shortly, but now we're going to look at the equation of a circle. In grade 11, the center is always 0, 0. And the equation of the circle is x squared plus y squared equals r squared. Now for some of you that might ring a distant bell. Isn't that Pythagoras' theorem? Yep, you're absolutely correct. And that's where the definition of a circle also comes from. Let's have a look at a couple of examples. Well, the first I could say is, if I have the point 3, 4 lies on a circle, what is the equation of the circle? Very straightforward. 3 squared plus 4 squared will be 9 plus 16, which is 25. Square root of 25 is 5. So the equation of the circle will be x squared plus y squared is equal to 5 squared. I just prefer writing 5 squared because that's the radius. If you had to sketch a little diagram, there would be your circle, center, 0, 0. Your x-intercepts would be 5 and minus 5. And your y-intercepts would also be 5 and minus 5, just as I have it on screen. If I was given a diagram, and for example, I was given the point 5, 12, and asked, what is the equation of the circle? I would use x squared plus y squared is r squared. So x squared plus y squared will be equal to 5 squared plus 12 squared, which is 25 plus 144, which is 169. Yep, 13 squared. So the equation of the circle is x squared plus y squared is equal to 13 squared. You can write 169, not a problem. Now, I'm sure some of you have also realized that I'm using Pythagorean triples, and that's why the arithmetic seems so quick and easy. 3, 4, 5, 5, 12, 13. Remember, for those of you who are really wanting to get good marks, you've got to remember those two Pythagorean triples. They pop up in trigonometry all the time. Slightly more difficult question now. If you're given a circle and you're given a point on the circle, let's say that is the point 2, 1, and asked, what is the equation of the tangent to the circle at 2, 1. Now, what are they talking about a tangent? A tangent would be like the tar road is to your motorcycle tire. It touches it at one point only. Drawing it in here. There is your tangent, and there is the point of intersection. Also, for those of you who remember your Euclidean geometry, the angle between a radius and the tangent is 90 degrees. Let's go and answer our question. What is the equation of the tangent to the circle? Now really, the circle, all the circle tells us is that the radius and the tangent are at 90 degrees. So my slope of my radius will be equal to 1 over 2 or a half. How did I get that so easily? Remember, I'm going from 0, 0 to the point 2, 1. So 1 minus 0 over 2 minus 0 is a half. Double checking, is it positive? Yes, it's a positive slope. It's going up to the right. What does that mean for my tangent? Well, the slope of my tangent must be equal to negative 2. How did I know that? Well, I know that a half times negative 2 is negative 1. And remember what we did a few minutes ago? We looked at perpendicular lines. If the product of the slopes is minus 1, the lines are perpendicular. Right, I've got the slope of the tangent at negative 2. How am I going to work out its equation? Yes, substitute in the point. Absolutely correct. Y minus y1 is equal to m into x minus x1. So y minus 1 is equal to negative 2 into x minus 2. I've substituted in the point of contact of the tangent and the circle, and I've substituted in the slope of the tangent. Tidying this up, y is equal to minus 2x minus plus 5. Negative 2 times 2 is 4, plus the 1 from the other side is 5. That is the equation of the tangent. Cute question, isn't it? By the way, what is the equation of the circle? Just to reiterate. Well, x squared plus y squared is equal to r squared. So 2 squared plus 1 squared is equal to 5. So in this case, the length of the radius is root 5. My equation, however, is x squared plus y squared is equal to 5. And there we have it. Circles in a nutshell. I'm going to look at the properties of a whole lot of quadrilaterals, just to refresh your memory and also to point out some interesting aspects which you need to keep in mind. The first one I'm going to look at is the trapezium. Two sides are parallel. That's it. If we start with an irregular quadrilateral, that means all the sides are different angles, all the vertices are at different angles, all the sides are different lengths. The first piece of standardization that we come to from definition is one pair of sides are parallel. And there we go. It's the only property that it has. So if you're told that ABCD is a trapezium, well, you know that one pair of sides are parallel. That's all. Just in a point of notation, I would call this trapezium ABCD. Why? Well, that's the order from A to B to C to D and back to A again. I know that someone out there would like to say, I don't like it in order like that. I'm going to call it CDAB. Perfectly correct. Or CBAD. Absolutely fine. As long as you go around the perimeter, around the exterior of your quadrilateral, you name the vertices in the order that they arrive in. Just to reiterate, trapezium, one pair of sides are parallel. Finished. If we move on to the rectangle, quite a lot of properties. Well, here we have opposite sides are equal and opposite sides are parallel. So I'm going to pop in the parallel lines over there. The interior angles are all at 90. And the diagonals are equal in length and bisect each other. Now that's quite an important property, because if you've got a rectangle and you've got to find the distance AC, but you're not given the point A and C, if you could find out the distance BD, you've got it. Or perhaps you find out from D to E, then you could double it. So please, once again, just run over your properties of your quadrilaterals. Moving on. If we come to a parallelogram, now remember I gave you the hint that this one is the one that is usually examined. Opposite sides are parallel, and that is why we call it a parallelogram. Both pairs of opposite sides parallel. That's our definition. From that, we've been able to prove that both pairs of opposite sides are equal, the opposite angles are equal. In other words, that angle at A and that angle at vertex C are equal. Similarly, B and D are also equal. And the diagonals bisect each other. Now, unlike a rectangle, AE and EC are not the same length as BE and ED. However, here's an interesting snippet. E is the midpoint of AC and BD. Question: how could we prove that the diagonals bisect each other? Well, let's have a look. Is the midpoint of AC the same as the midpoint of BD? If they do, they bisect each other. Nice question. If we go to a rhombus is a squashed square. All the sides are equal, opposite sides are parallel, but have a look at what happens on the interior of a rhombus. Your diagonals bisect each other at 90 degrees. In other words, the diagonals are perpendicular to each other. And I can just see some of you rolling your eyes and saying, oh my goodness, now they're going to bring in perpendicular lines with a rhombus. Yep, the examiners are. Also note that the interior angles are bisected by the diagonals. So that sets up a whole lot of interesting triangles which have base angles that are the same. Isosceles triangles. There we go. BDC is isosceles. Why? Because angle D and angle B are the same in size. The square. Almost everything is the same here. All you need to do is have a look at it. Interiors are 90, diagonals are bisect at 90, diagonals bisect each other as well. In other words, AE is the same as EB. You can see that because of the 45 and 45. So we have an isosceles triangle as well. Opposite sides are all equal. All these sides are equal, in fact. Diagonals bisect at 45 degrees. And there we show 45, 45, 90. Lovely. It has a long list of properties. Let's move on. A kite. Now, a kite, a regular kite, the adjacent pairs of sides are equal in length. Those two sides are equal in length, and those two are equal in length. So an alternate version of a kite could look like that. What is lovely about a kite is that the major and minor diagonals, the major being the long one, and in this case from top to bottom, and the minor diagonal, in this case from left to right, bisect each other at 90 degrees. There we have it again. A whole bunch of right angles, perpendicular lines, right angle triangles. Our minor diagonal and our major diagonal are perpendicular to each other. Now, in this family, we have a thing called an arrowhead. The reason why it's exactly the same is that adjacent sides are equal in length. That side over there and that side over there are equal in length. And similarly, this one over here and that one over there are equal in length. Now, what about this major minor diagonal thing? Well, if I drew in my two diagonals, yep, they would be at 90 degrees. So in the family of kite, we also have the shape arrowhead. Just remembering that the major diagonal bisects the opposite angles. And that is where we get this result over here, that angle C is bisected and angle A is also bisected. The minor diagonal doesn't. Reiterate, major diagonal bisects the opposite angles. Let's move on. What I've done is I've set up a little diagram to help with classification of quads. If you can remember the way this happens, it's going to assist you to remember all the little bits and pieces that happen. We start off with a trapezium, and we remember trapezium, one pair of opposite sides parallel. Now what happens if I have one pair of opposite sides parallel and I add to that the other pair of opposite sides also parallel? Well, yep, becomes a parallelogram. Here's a one-mark question. Is a parallelogram a trapezium? Well, what's the definition of a trapezium? One pair of opposite sides parallel. Does the parallelogram fit that? Yes, one pair of opposite sides is parallel. So a parallelogram is a trapezium. Now, once you've got your opposite sides parallel, you know that you have your diagonals, you know that the diagonals bisect each other. And then what we're going to do is we're going to make a parallelogram with one interior 90. If one interior is 90 degrees, the other ones are all 90 as well. How do we remember that? Well, remember back in grade 8 if two parallel lines are cut by a transversal, the co-interior angles are equal? Well, we said that this was a parallelogram, so the opposite sides are parallel. So if that one over there is 90, the other one has to be 90 as well. Is a rectangle a parallelogram? Absolutely yes. If we decide not to make one interior 90, but we decide to make the sides equal in length, we'll go from our parallelogram to our rhombus. Yes, a rhombus has the same qualities that a parallelogram has. It's both pairs of opposite sides are parallel, but in addition to that, the rhombus has all sides equal in length, not just both pairs of opposite sides. And then once we combine all the qualities of a rhombus and all the qualities of a rectangle together, we get the ultimate quadrilateral, the square. There it goes. Interior is at 90, both pairs of opposite sides equal and parallel, all sides are equal in length. The diagonals bisect at 90, they bisect the interior angles, and we have every possible quadrilateral attribute put onto our dear square. Sitting on the corner, flying in space, is our kite, with adjacent sides equal, and our arrowhead, the same family over there. So, another lovely question, and you might like to debate this with some of the juniors at your school, because I'm sure that they haven't realized this. Is a rectangle a square, or is a square a rectangle? Well, a square will always be a rectangle because it has all the properties of a rectangle. A rectangle will only ever be a square if its adjacent sides are equal. So, a square is always a rectangle, but a rectangle is not always a square. An interesting point of debate. Lastly, just talking about a couple bits and pieces, special triangles, an isosceles triangle. How would we prove a triangle is an isosceles triangle? For example, those two sides are equal. Well, we could use distance formula. Remember analytical geometry? Got to use analytical methods. We can't use sketch and our protractor. So we'd use distance formula. We could, if we wanted to, work out the angles of the interior sides, interior angles, and if they were equal, we'd know it was isosceles. How would we do that? M equals tan theta, our angle of inclination. Yep. Remember, with analytical methods, usually drawn on a Cartesian plane, we can read off the coordinates, or the coordinates are given to us. So it's not a problem. Use our formula on the formula sheet. The next one, an equilateral triangle. All three angles are equal and all three sides are equal. It might be called an equiangular triangle. Doesn't happen often, but if it does, an equiangular triangle and an equilateral triangle are the same animal. Three sides, all sides equal in length, all three interior angles, same size. We've already discussed our right angle triangle and how we would prove it right angled. Yes, we would either use Pythag, or perhaps we could use the product of the slopes being -1, and then we would know that it was a right angled triangle. I now would like to do an example with you on finding the vertices of a parallelogram. Remember, I said to you, parallelogram was the most popular shape in questions. Here's an example. If I was given a Cartesian plane and I was given a couple of points. I was given the point -1, 2, and I was given the point 4, -1. Over here, I was given the point -3, 3. And I was told that there was another point over here somewhere, and I'll call it point D, and I had to work out its coordinates. I'm sure some of you are thinking, well, if I work out the diagonals and I know they're going to bisect each other, I could work out the slope of that line and have the distance from here to there. Yep, that would work. Take a couple of pages of working though. So what I want to do is to show you how to work this out using ratios. There's no working out to be done. It's all intuitive and by inspection. If we have a look at how many x's do we move across? Well, we go from -1 to 4. So how many x's have we translated? 5. So what is going to happen to the other 2 points? They're also going to translate by 5. So from -3 to what value is going to give you a translation of 5 units to the point D, 2 something. Some of you are saying, how did that happen? It's so quick. Doing it this way, intuitive by inspection, is very easy. Let's have a look at the y values. How many do the y's go upwards? From -2 to 3. Yep, they go up 5 units as well. So from -1 to what value is 5 units? To the point to 4. Very good. And so the fourth point, the fourth vertex of our parallelogram is the point D, 2, 4. There's no calculation required. All you're doing is seeing how many the x's shift across on one side and doing exactly the same to the other side. And how many y's is it shifting on one side and doing exactly the same to the other side. Right, that is basically everything in a nutshell. What I'm going to do is I'm going to pick an exam question, a typical exam question for analytical geometry, and I'm going to work through it. Here it is. You're given a grid with points A, B, and C, and they want the gradient of line BC. The gradient of line BC. I'm not going to be worried about drawing it in. If you don't want to draw it in, you don't have to. You can just do the calculation. So m, which is our gradient, is the change in y over the change in x. 2 minus -2 over -3 minus 1 gives us 4 over -4, which is -1. I chose C as my first value and B as my second value. Not a problem. So there is our gradient of line BC. 2 marks in the bag. Moving to the next little bit, and I'm going to draw that in and follow that m here was -1. Hence, or otherwise, what is this word hence? What does hence actually mean? Hence means use what you've already done in the other subsections and use that answer to answer this question. The examiners also put in the proviso or otherwise, in case you didn't quite get it. Determine the angle which BC makes with the positive x-axis. So what are they looking for? They're looking for that angle and there they are nice enough to tell us the angle of inclination. So what are we going to do? We're going to use the formula m equals tan theta. There is our little theta over there. Yes, m equals tan theta. It's on the formula sheet. M was -1. So what is tan of what angle is going to give you -1? Some of you already know. 135. It's a special angle. But let's do it on our calculator and we can double check. Right, so we go. Shift tan, -1, and we get -45. What does it mean for -45? It means this little bit underneath there was 45. So theta must be 135 degrees. Our angle of inclination. We know that it can't be 45 because it's not an acute, cute little angle. It's an obtuse angle. Moving on. Part C. Determine D if, determine T if D, being the coordinates T7, is collinear with B and C. Well, what do we know about the slope of BC? It's -1. So what do we know about the slope of BD, or if you prefer, CD? Yes, it's got to be -1 as well. So I'm going to use the point B. And I'm going to say the slope of BD is -1. And I'm going to do a calculation. Well, from 7 minus -2, D I've taken as the first one, over T minus 1. I've now set up my equation through knowing that collinear, if points are collinear, the slopes between them have to be the same. So multiplying this out, I get -1 into T minus 1 is equal to 7 plus 2. Negative T plus 1 is equal to 9. So therefore, T will be equal to -8. So the point D is -8, 7. Let's have a look where that would be. -8, 7 would be over here somewhere. That is where D would be. What do you think is going to happen soon? I'm going to guess that they're going to ask us to have a parallelogram A, B, C, and another point somewhere. But let's move on and have a look. Determine P if E, which is the coordinates 5P, if it is the midpoint, if A is the midpoint of BE. I think we need to go to our diagram. They're saying that E is somewhere over here, and from B to E, A will be our midpoint. So E is going to be over here somewhere. That length and that length are going to be the same. We know that midpoint is the average of the x's and the average of the y's. What was this point over here? This was the point 5P. So we know that over there it is 5P. All right, we need to find P. 4 will be equal to P plus -2 over 2. Now, where did I get that from? Well, that is my y value, that is my y value, and that is my y value. So all I'm doing is taking the average of the outside 2, and I've got to get the middle one. So going back here, 8 is equal to p minus 2, so p would be equal to 10. Using our midpoint formula in a slightly different way. Moving on to our next sub-question. Determine the equation of the perpendicular bisector of BC. Wonderful, there's BC. Perpendicular bisector. It is going to lie somewhere over there, cutting it at 90 degrees, and it's going to cut it in the center. So what do we need to do in this case? First thing we need to do is find the midpoint of BC. And I'm just going to call that M. So M would be the point minus 3 plus 1 over 2 and 2 plus negative 2 over 2. And our midpoint M is going to be the point negative 2 over 2, which is negative 1, and 0 over 2, which is 0. That means that my diagram over here wasn't very far off. But our midpoint is minus 1, 0. We've got our midpoint. Perpendicular is the next bit. Now, we've got the slope of BC. We worked it out in part A, part 1. It was negative 1. What times negative 1 is going to give you negative 1? Remember, if the product of the slopes is minus 1, the lines are perpendicular. Of course, it's going to be 1. So our slope of our perpendicular bisector is going to be 1. All I have to do is pop this into my equation for a straight line, which is y minus y1 is equal to m into x minus x1. You're right, that's the way I prefer. So y minus 0 is equal to 1 into x minus minus 1, and tidying that up, I get that that is the equation of my perpendicular bisector. Now please, guys, when you write down your answers, make sure you label what you are doing. The midpoint of BC, M, and put its coordinates. Please don't just do a whole bunch of calculations and have the examiner scurry over your page trying to find a place to give you marks. Please set it out logically. We need to find the midpoint, we need to find the slope of the perpendicular bisector, we need to find the equation of the perpendicular bisector. Vital that you do it in order and correctly. Determine the coordinates of point D if ABCD in that order, spoke about that a while ago, is to be a parallelogram. So what we're going to do is we can go from A to B to C, and somewhere over here is going to be our point D. Okay, so what are we looking for? Let's have a look at the x's. From B to C, how many units do the x's change? From 1 to minus 3, they change 4 units. So from 3 to what are they going to change 4 units? You're right, minus 1. Let's have a look at our y values. From minus 2 to 4, how many units do they change? 6 upwards. So from 2 to what value would they change 6 upwards? 8. So our answer would be D would be the point, just double checking our calculation, minus 1, 8. Right, let's move on to question 2. Well, question 2 asks us to show that it's an isosceles triangle. How are we going to do that? I don't want to have to do angles of inclination, so I'm going to use distance formula. What I'm going to do is I'm going to check the distance of AB. Well, the distance of AB, let's remember our formula, square root xb minus xa all squared plus yb minus ya all squared. So it'll be 1 minus 5 all squared plus minus 7 minus 5 all squared. Right, and that gives us the square root of 1 minus 5 is minus 4 squared, 16. Negative 7 minus another 5 is negative 12 squared is 144. Square root of 16 plus 144 will be the square root of 160. Let's check what the distance of BC is going to be. Well, distance of BC, similarly, minus 7 minus 1 all squared plus 1 minus 7 all squared. Okay, so that gives us negative 8, 64. And that gives us 1 plus 7 is 8 squared, 64. What do we get? We get the square root of 128. Any luck? Not yet. So what do we have to do? We have to find the distance of AC. Well, the distance of AC, let's get our coordinates, will be 5 minus 7 all squared plus 5 minus 1 all squared. What does that give us? Well, the square root of 12, which is 144, plus the square root of 4, which is 16. Aha, we've got it. Square root of 160. So what are we going to say to finish off this question? We're going to say that AB is equal to AC, therefore ABC is isosceles. Right, let's go on to part B. Determine the equation of the circle. Now remember, back on your formula sheet, equation of a circle, x squared plus y squared is equal to r squared. Circle, center at the origin, just as well as says that, it's grade 11, and passing through point A. Right, we don't need to do a diagram, all we have to do is a calculation. So we have x squared plus y squared is equal to r squared, which gives us 5 squared plus 5 squared, which is 25 plus 25, which we all know gives us 50. So our answer, x squared plus y squared is equal to 50. Quick and easy 3 marks. Make sure you get them. And remember to look on your formula sheet. In fact, a lovely exercise is to test each other on the formula sheet. Grab your formula sheet. What's that equation? And the first one out of your mates to answer gets the prize. Okay, let's go on to part C. A, B, and C are vertices of a triangle. Determine the equation of the perpendicular bisector, there it crops up again, of BC. Now, the first thing we're going to have to do is work out the slope of BC. Well, I'm going to say 1 minus 7 over minus 7 minus 1, which gives me 8 over negative 8, and just extending the page, in this case, is -1. So our slope of BC is -1. But that's not the slope of the perpendicular bisector. The slope of the perpendicular bisector is equal to 1. If the product of the slopes is -1, the lines are perpendicular. Fantastic. What point does it go through? We don't know yet. So the midpoint of BC, midpoint of BC, we will have to use our midpoint formula. So what is the setup for our formula? Is over there. Well, let's have a look at the numbers. B is -7, the x value, and C is 1. And B, the y value, will be 1, and C, the y value, will be -7. So the midpoint will be -6/2, which gives us -3, and it will give us -6/2, which is -3. Quite ironic that it's a point that lies on the line y equals x. Let's see what the equation of the line will be. I know, just for those of you who prefer y equals mx plus c, I'll do it that way. So we have y equals mx plus c. We've got the slope of our line, which is 1. And we are now going to substitute the point, this midpoint, which is -3, -3. Goodness me, our C value turns out to be 0. So what is the equation of the perpendicular bisector? Y equals 1x plus 0, or as most of us call it, y is equal to x. Quite a coincidence that I talked about that a few moments ago. Or is it? The last little bit in this question 2. Determine the equation of the line through A. Got to go through A, and it's got to be parallel to BC. Now, here we need the slope of BC. Well, let's do it again. -7, -1, the change in the y values, over the change in the x values, which in this case gives us -8/8, which is -1. So what have I got here? I've got an equation, because it's parallel, it's going to have a slope of -1. So the slope of our line is going to be -1. And it is going to charge through the point A, which is 5, 5. I think something fishy's up. Let's have a look. Substituting everything into my favorite equation, y minus y1 is equal to m into x minus x1, we get that y minus 5 is equal to -1 into x minus -5, which gives us x plus 5. Tidying this up, y minus 5 is equal to -x minus 5, which for most of us will be y is equal to -x. Get out there, be the best you can be, and good luck in your final exams this year.